Hey everybody, welcome back to Physical Science today. We don't have a ton of notes because you probably have most of the answers already according to your assignment yesterday. So now you get to see if you were correct or not. Okay, so the first thing was, what the questions were, one of them was, what does the symbol mean in molecular formula, right? Or a compound formula might be the better name for it now because we have two different names. One is molecule, and the other is formula unit. So, but they're both called compounds. So the symbol in a compound tells what kind of elements are in there. So if I have a big H, what do I have? If I have a big C, little L, what do I have? If I have an HE, what do I have? Okay, very good. So, you know what that means. Tell us what kind of elements. Okay, so that should be part of your notes. You probably already have it there, though, because you did your assignment yesterday, right?
Yeah.
For example, NaCl. Sodium and chlorine together. Right? As one compound. Okay? H2O, hydrogen and oxygen. You notice anything different between the first example and the second example?
The second example has a number in it.
Thank you very much. That's exactly right. The second example has a number in it. And the kind of number it is called a, yes, that's correct, it's called a subscript. Because it's below, like a submarine is below the water, right? A subscript is below the written, the script. Right?
Great.
Okay. So we might talk about subscript. The definition of subscript is how many of each element, but I want you to put in here how many of each element just before the subscript. So it's two hydrogens, it's not two oxygens, right? See that right there?
Wait, just before what?
The subscript right here is 2. Right? You see that?
Yep.
And that means there's 2 of the elements that is symbolized by the symbol just before the subscript. So in other words, there's 2 hydrogens. There's not 2 oxygens.
If it were like 2 of
Okay, so you guys can get that. You figure that out. For example, NaCl, there's no subscripts. There's just 1 sodium per 1 chlorine, right? So it's 1 sodium, 1 chlorine. But if we look at H2O, that means there's 2 hydrogens and 1 oxygen. So the next little definition is superscript. Super is above, script is, what you wrote. So superscript would be above that. Subscript was below. This tells the charge of an atom or a molecule. Okay? So for example, Na plus has 1 sodium with a positive charge. My question is to you, what happened to the sodium atom in order for it to have a positive charge? Well, you're thinking about what a sodium has, right? So you guys all know that a sodium has protons. Do you agree?
Right?
Sodium has protons and sodium has electrons. Protons have positive charge, right?
Right.
Electrons have negative charge.
Right.
So elements start out with, like for instance, let's look at sodium. Sodium has 11 protons, and that's 11 positives, right? And it also has 11 electrons, right? That's what we did, oops. Isn't that what we did for the last? Oh boy. So sodium atom, like we did last time, the atomic number of sodium is 11, so that means it has 11 protons. Do you agree? So it means it has 11 positive charges. Do you agree?
Yes.
And it also then has 11 electrons, right?
Yes.
And those 11 negative charges are canceled out by the positive charges to make the atom electrically neutral, correct?
Yes.
Any questions about that? Okay, so back to the question then, what happened to sodium? Did it lose a proton? Did it gain a proton? No, because if sodium gains a proton, it has 12 protons. What element do I have if I have 12 protons?
Magnesium.
Okay, so that didn't happen. So what did happen?
It got rid of the electron.
Yes, lost an electron. And if you remember from yesterday, you would remember how we talked about getting an octet. And look at where sodium is right now. It's right here, right?
Uh-huh.
How many valence electrons does it have?
One.
One. And if it loses that one valence electron,
It blows up.
It becomes an octet.
it has an octet, which is because it has the electron configuration of a neon, the noble gas that has an octet. Does that make sense? That's a very, very great question. Thank you very much. No, okay, atoms will never lose protons unless they go through some atomic change, like in an atomic bomb, then you can split the atom. Like you can take protons away from the protons in the nucleus. Or if you have a radioactive atom like uranium, it can eject what they call an alpha particle, which is a helium nucleus. 2 protons, 2 neutrons, and it can lose protons. But other than that, atoms do not ever lose protons or gain protons, because if they do, if it lost a proton, it wouldn't even be sodium anymore. What would it be if it lost a proton? It would actually be neon. But if it loses one electron, it has the same chemical nature that neon does, because chemistry and the nature of chemicals has everything to do with the electrons, but not just the protons. In fact, it has everything to do with the electrons, and more importantly, the valence shell electrons. So we would never lose protons and get like a different atom, but we could lose electrons. And so the atom of magnesium acts like helium, neon, but it actually is still magnesium. Okay, so that's the superscript idea. Okay, so the rest of the notes have been revealed for the rest of the day. Okay, so look, that makes perfect sense. Then sodium would actually... Okay, how about S-2? What does that mean?
Negatively charged.
That's a sulfur atom that has a -2 charge. It means it gained 2 electrons. Now, should we look at the periodic chart to make sure that that makes sense?
Yes.
Okay. So we look right here. Where's sulfur? Sulfur's right here. You- Here's sulfur right here. See that? Okay, so look. If you look at sulfur, it has to get... It's going to have to gain 2 electrons to get an octet. Do you agree?
Yeah.
Because you have to go 2 over to get to argon, which is the closest noble gas, and the closest way for it to achieve an octet. Okay, so that makes sense. Okay, how about parentheses? Parentheses. So do you guys all know what parentheses are?
Yeah.
See down here? The NH4 is inside a parenthesis. So, what this is NH4, this acts as one group, just like an atom would act. But this is acting like one atom, but it's a group of atoms. So this is what we call a polyatomic ion. Okay? So the word poly, what does that word mean?
I think it's 2 or
Poly means 1.
Well, it's more than one. It's many. And then polyatomic, it's more than one. Poly means more than. It's probably a little bit better definition, but monatomic would be one atom. Polyatomic would be multiple atoms. So if we have a polyatomic ion, Okay, see that word right there, polyatomic ion?
Yep.
Might want to add that to your notes. That is what we call NH4. That's also what we call OH. So, in fact, most things that we see in parentheses like this are groups of atoms that act as one ion. Okay? So that's the definition of polyatomic ion. It's a group of atoms that act as one ion. Okay, so we have to separate those with these parentheses to show that, hey, I'm talking about, in this case, I'm talking about the NH4 as one thing. Okay? And so when you look at this now, see, remember we said that the subscript meant that it was the number of atoms of the element just before the subscript? We said that, right?
Yep.
But
now, what do you think it means?
That means
that all of those
all
atoms.
of the numbers of H4.
Yeah, so there's 3 groups of NH4 now. So NH4 will float around together in a polyatomic atom, and this, since it's outside of the parentheses, means that there's 3 NH4s.
You can distribute it from.
Yeah, and if you want to figure out the total number of atoms there, you can use the distributive property to figure out, well, geez, that must mean I have 3 nitrogens and 12 hydrogens. But I'd rather have you understand that it's 3 groups of NH4, because those NH4s are stuck together in a molecule, but that whole molecule acts as one ion. Okay? Okay, so the question is, what does that mean that it's N3H12? Well, that is the number of atoms, but a polyatomic ion has the NH4 stuck together. So if this is, I'm going to draw a picture of the polyatomic ion NH4. Okay, so there'd be one H up here. Oh. And I'm signifying a connection with this right here. So that's going straight up from it. Okay? Then like a tripod, there's one that comes out this way. Does that make sense? And then there'll be one that comes out this way. And then there'll be one that goes back. So I don't know if that makes sense or not, but you've seen a tripod, right? That you put a camera on or something like that? And you have the 3 legs. So these would be the 3 legs, and then this would be the camera. And so that's what an NH4 molecule looks like. So, and then this whole group then has these parentheses around it, and then the whole group is going to have, a positive or a negative charge. Okay? Okay, so now look. So this would actually have then a -1 charge. And what that means is that extra electron here, it floats around all of these pieces. It's not just floating around just one, it's floating around the whole entire group. That's why they call it a polyatomic ion, because this electron is being shared by all 5 of these pieces in here. Okay, and that's why you'd signify it later when you get to chemistry. Okay. So same with the OH, then if you looked at the the way the OH comes together, it'd be OH like this. Okay. See, this is a little bit further past the dot diagram. This would be called the Lewis structure. And then this whole polyatomic ion here would have a -1. Now, I've told you a little bit more than this, just so you kind of understand that it's not just as simple as N3H12. But at this time, I'm not expecting you to know this part, but at least when you see in chemistry, you'll be able to say, hey, I saw this before. Any questions about that? Parentheses. Okay. Okay, so molecular mass then is the last thing that we're going to talk about today. And that would be the mass of the molecule. And remember that we said that these things are so small, they came up with a new unit to mass these. And what was that unit called? Not grams or kilograms, but what?
Hexagrams.
AMU, or atomic mass units. Very good. Right here, they're AMU, atomic mass units. So this is how you figure out the molecular mass of a substance. So molecular mass is the mass of one molecule. And the way you do that is you add up the mass of the most common isotopes of each element in the molecule. And then you make sure you look at the subscripts to account for every atom. Like for example, H2O. Okay? So, H, the most common isotope for H is going to be, if you look at your periodic chart, can you look at your own periodic chart at your desk? Can't really see the number in here, but the most common isotope is going to be 1, do you agree?
Yeah.
And then for oxygen, what is it? The most common isotope? 16, right? So if we're looking at H2O, okay, H2O, we have 2 hydrogens, 1 oxygen, so we're going to have 2 hydrogens, each one has 1 AMU, and then, which means that we have, a total of 2 AMUs then, right? Okay, and then 1 oxygen that has 16 AMUs, okay, I'm going to just put times 2 over here. Okay, so our molecular mass then,
18.
our molecular mass for H2O is 18 AMUs. Okay, let's do another one. Let's do sodium chloride. Can you guys figure that one out? So you look at your periodic chart, you see sodium has 23, right? That's the most common isotope. And chlorine is 35.
Yep.
35, okay. And they each just have 1 because there's no subscripts, so that means that the subscript number 1 is assumed. So it's going to be a total AMU of 58 AMUs, okay? 58 AMUs. Okay, here's another molecule, C6H12O6. Have you ever heard of that?
Yeah.
This is a beautiful molecule that means a lot to us and our life. Okay, can you tell me the molecular mass of this molecule, please? Okay, so carbon has 12, right?
It's 4.
12 times, doesn't carbon have 12? Yeah, so it's 72 from carbon. Hydrogen has 1 times 12. That's 12. Oxygen has 16, right? Times 6. That's 96.
Yeah, I added those.
Okay, I can multiply, but I can't add all this together. But what all does this add up to? 180 AMU. Is there anybody that doesn't understand how I did that?
I got it.
I have no idea.
Okay, so look, here's your assignment. Worksheet 1. Oh, we don't want to cancel that out. Worksheet 1, which will be given to you tomorrow when the sub is here. But today you have to make flashcards of the polyatomic ions given in class with the name on one side and the formula on the other. You will memorize these for the quiz and the tests. Okay, here's your first flashcard. I'm showing front and back on the same side. Hydroxide, it's OH, and the whole thing is negative. It's a polyatomic ion. And your next polyatomic ion flashcard, front should say chlorate, and the back should have, in parentheses, a Cl-O3. The whole thing is -1 charge. And your third flashcard is acetate, and it's a polyatomic ion with a -1 charge, and it's got a C2H3O2. Your next card should say phosphate, and the formula for phosphate, the polyatomic ion, this has 3 extra negatives, or 3 extra electrons. PO4 -3. Phosphate. And our next one is carbonate, and it's a CO3, and they all share 2 extra electrons, so it has a -2 charge. And your next polyatomic ion is a cation. It's a positive. It's ammonium, it's NH4, and it had lost an electron, so it has a +1 charge. And our last two are sulfate, and that's an SO4 with a -2 charge, and then nitrate, which is an NO3 with a -1 charge. So these are the flashcards I expect you to make, bring to school tomorrow, and then quiz each other on them for the quiz on Friday. And hopefully this helps you. Have a good day.